Morning students. Today we will do, actually yesterday I have told you that the types of set: finite set, infinite set, equal set, and empty set also. Now we see some example of that kind only. One question is being good. Example number 18. Sorry, example 8. Second question, that a is equal to n, where n belongs to z, and n square less than or equal to 4, and b is equal to x, such that x belongs to the real number r, and x square minus 3x plus 2 is equal to 0. Actually, what we are told to, which of the following pair are equal, we just have to prove that, have to tell that whether a equal to b, meaning whether these two sets are equal or not. So this is a question, very easy question. I explained that how to get the answer. Look at this is set A, n square less than or equal to 4. Some things you have to know. Slowly we will go, no matter at all. N meaning natural number, but it is n belongs to z, it is given. Z meaning integer. So okay, normally n is taken in natural number, but this time n belongs to z, and z is itself what? Integer. You know integer, negative value, 0 and positive value. But you have to take all the integer which satisfy this one, meaning you have to go with some n which satisfy this one. What is integer? You know that integer 0, 1, 2, minus 1, minus 2. These are integers. So put one by one. Will you put 0 here? 0 square less than 4, true, meaning 0 is one of the element. 1 put 1 square less than 4, it is true, meaning 1 is also element. 2 put here, 2 2s are 4, which is equal to 4, it is also an element. You also can put minus 1. Look at it is z meaning integer, meaning n can be attain the value of integer also. So when minus 1 will be put, minus 1 square is also 1, which is again less than 4. Minus 2 will put, minus 2 square is 4, which is again equal to 4. So full meaning of that, in this set particular, how many values will come? These values will come. And think about, whenever you want to make sets are equal, please convert your set builder form into the roster form, because roster form gives you good information about the set. Now this is A. Now similar B. So B is what? X, such that x belongs to R, and this equation. So this is very easy again. X is actually R, means real numbers, a lot of real number, infinite real number they are, but only just to satisfy this one. And this is none else, it is a quadratic equation. It's very familiar to you. Taking for only x square minus 3x plus 2. I don't want to do the tough thing because you know it very well. This is quadratic equation, and by middle term splitting or formula method, you also remember that we split to 3 in 2 parts, such that multiplication is 2 and addition is 3, like that. I don't think that I have to repeat it, because in class 10th you already have read all. Now when multiply 2x inside it, 2x plus 1x plus 2, and open the bracket, 2x minus x, take out x common, x minus 2, minus 1 common, x minus 2, ultimately x minus 2 common, what remaining it is x minus 1, and 2 answer we will get. First by this and second by this. So x is equal to either 2 and x equal to 1. Whole sense is, what is b now? What is b? This is b is none else, it is a solution 1 and 2, because it is only satisfying this one. So this was a set builder form, but this is a roster form. Now compare, that is b and that is a. So these are equal? No, they are not equal. So I would say that a and b are not equal sets. Not equal sets. And when a and b will be equal? When all the elements of a and b are same. Even there will be a disorder, no matter at all. If they are not arranged in a order, no matter at all, but element should be same. That's then only both set can be equal. So this is a question, I think, very easy question for you. Now let me skip, let me come on the some question of the exercise. In exercise we have 1.2 and question says, first question says, which of the following are example of null set? Null set. Which is a null set? We have to identify which is a null set. So I have question number, suppose I ask you that 2. Question number 2, set of even prime. I ask you. Now try to make the set. Are we able to make the set? Does any element comes here or not? Like set of even prime. So what about the prime number? Prime number begin with 2, 2, 3, 5, 7, 11 and so on. But it is only asking about even prime. So even prime is only 2. So this is not the empty set, this is not the null set because one element is there. I would say it's not a null set. You know that question is not so big, but you know concept must be known. That's why I have told when you will form the set, if any element is inside the set, definitely it is not empty. It is not a null set. Okay. Now next question, one question we want to take here, question number 3. What says it is? X says that X is natural number where X less than 5 and X greater than 7. So what is its meaning? I think initially a student cannot think about what is its meaning. I would say and shows common element. And shows common element. You have to find all those X which satisfy this and this both. This and this both. Okay. This time I want to make, because you don't have a good knowledge about that, still I tell you, this is number line, real number line. This is 5, this is 7, this is infinite, this is minus infinite. Now I ask you, X less than 5, meaning X less than 5 meaning all those which are less than 5. And X greater than 7 meaning all those which are greater than 7. And to see whole the picture, if I ask you that what is a common element, one can easily understand that there is no common element. Because of this X greater than 7 meaning 8, 9, 10. X less than 5 meaning my 4, 3 and so on, so on. So what? How many common elements? No common elements. One should know about that and meaning common element. Please keep remember. So I would say that this is a set, actually what set? Empty set, because there is no common element in that which satisfy together both X greater than 7 and X less than 5. Someone will choose suppose 8, X equal to 8, which satisfy this one greater than 7, but it is not less than 5. So wrong it is. So finally I would say that there is no element which satisfy both together, so that it is an empty set. Okay. So this was a question which I wanted to tell you. Now few questions again we see. Finite and infinite, I have already told you that set of integers, set of natural numbers, set of a real number, set of a rational number, they all are infinite set. And you must know bounded set, always bound. Even a question is written here 1, 2, 3 and 99 and 100 like that. But don't afraid, it is still finite, because even this is not all the element written here, dash or something like 1, 2, 3, but last element is there, meaning this is a finite set. This is a finite set. One should know, catch the sequence, 1, then 2, then 3, then 4 will come, 5 will come. You can drop, but if last number is written, it is a finite. If last number is not there, meaning it is none, is 1, 2, 3, 4, 5 is what? They are natural number. Then this is what? Infinite set. Okay. So this is the thing which I want to explain. Now I have some more question. Question number, I'll say question number 4. Question number 4. In question number 4, what I want to explain, whether, question says whether A equal to B. Question says whether A equal to B. Question 3rd I am taking. A equal to 2, 4, 6, 8, 10. B equal to X such that X is positive even integer and x less than or equal to 10. Now, one good thing which is here in the question, this a is very simply given. A is in what form? Roster form. And this is in our favor that we don't have to go with a because a is clearly given. We just have to b because b is actually in set builder form. So you guys change this in what form? Change this in roster form. Then you can identify that both are equal or not. So we'll just find b. These will just for the concept. Even in exam, if it will come in an objective question, in 1 mark question. So you just have to pick the correct answer by doing a simple work in rough section. So okay, I do. What is b? This is a set builder form. This is a roster form. Now catch it. X is a positive even integer. Positive even integer. Even positive. Look at 0, 0, 1, 2, 3, minus 1, minus 2. So what is even integer? X is a positive even integer. Even integers start with 2. 0 will not come in the positive section. Look at it is even, I know that, but it is not a positive. So positive will start from 2. 2 then 4 then 6 and so on, so on, so on. But we have a restriction that it is x less than or equal to 10. Meaning it can be equal to 10, it is less than 10, and it is a positive and it is even. So 0 is even, I know, but I can't take because it is not a positive. So we'll start with a 2. So we'll write 2, then 4, then 6, then 8, and then 10. I can't go ahead to 10 because it is a restriction. X either equal to or less than 10. So your answer is this one. So look at the check and answer A and B. So both are same looking. That's why A equal to B. It is answer. It is answer. I don't think that I have tell you much and more because these only 2 words very important. And this is a restriction of x which we followed here. Okay. This is the question. Now I'll go on next. Question we have. Fourth question is also very easy. X is a multiple of 10 and 10, 15. One can easily pick it that x says that x is a multiple of 10 and b is 10, 15, 20, 25. One should catch easily that multiple of 10 meaning what? Multiple of 10 meaning 10, 20, 30, 40, 50. These are multiple of 10 and this is 10, 15, 20. Obviously both are not same. So very common question they are. Don't afraid about all questions. So easy question. But don't leave them. Do in your fair copy. And let me speak now because I just came in mind that I want to say something that do prepare your copy, fair copy, write each and everything in that. If you have any trouble, you can consult with me at my WhatsApp number. I will tell you. Now we have a question. Fifth same, not discussing that, and sixth is also same. So I think please do try. If you really not can't make it, please inform me. I will tell you. Now I'll go on next new important word. It is a subset. It's very simple meaning subset. So look at, I tell you one thing. Let A be any set. Let A be any set, then a set B is called subset of A if all the elements of B is also element of A. Is also element of A. This is very simple. Even I have written 4 lines, but when I will tell you the meaning, you will get it so easy. Look at, I put example. Suppose A is 1, 2, 3, 4, 5, 6. This is the set A. Let A be any set. It is any set. Now, then A be any set, then a set B is a called subset of A if all the element of B are also element of A. All the elements of B are also elements of A. Meaning what I am taking, if I am taking 2 and 3 and 4 only. And look at these two sets. I have written that B is called the subset of A if all the elements of B all are also element of A, meaning look at the B, all the elements of B must be the element of A. 2 is here, yes. 3 is here, yes. 4 is here, yes. Meaning B is a small set, A will definitely be big set. All element of B is appearing in that A. This time B is called subset of A. If I will write here 7, then 7 here, but 7 is not here. So all the element of B are not element of A. That's why B is not subset of A. But this time, if it is a 4, something like any element you can take. But this time, all the element of B are also element of A. B is called subset of A. I would say that it is denoted by B subset A. Look at symbol B subset A. It is called B subset A. Don't use a line here, otherwise it belongs to. And the set here, this is a subset sign, B subset A. And I again say, which is not mentioned in your book, that B subset A and A is superset of B. B is subset of A and A is superset of B. So the second sentence is not mentioned in the book, no matter at all. You should remember B is subset of A. Okay, I ask you one thing more. Look at properly, a very important thing I'm telling you. Suppose A is 1, 2, 3, 4, 5 and 6. Suppose B is 1, 2, 5, 6, 4, 3. And I ask you what is B subset of A? Look at all the elements. 1 is here, 2 is here, 5, 6, 4, 3. All elements are equal. So I would say all the elements of B are also element of A. Even you know that all are equal. I know that actually it is not A, it is itself A. It is not B, it is itself A. Because all elements are same. So I would say that A is subset of A. If you're still confused, I tell you. Write it B. And I ask you that, does B subset A? So what is definition? All the element of B must element of A. 1, 2, 3, 4, 5, 6. Ultimately all elements are same. Meaning that what? All the elements of B are element of A. You will write B subset A. Yes, it is correct. Yes, it is correct. But ultimately you will see that B is none else, which is actually equal to A, because all elements are same. So B is not B, which is actually A. B is not B, which is actually A. So you will write A subset A. What you conclude? What you conclude? That every set is subset of itself. What conclude? Every set is subset of itself. Very important sentence I have told. Every set is subset of itself. Very important thing. Okay. These two are, I think, very good to tell you. Let me rub this, and want to tell you one more example of this, which is you have to go through this, and I tell you one thing. Look at this is suppose A, and now I ask you one thing, that find it all the subset. Find all its subset. One example. Would you think that 1, 2 is a subset of this? Because 1, 2 have a 2 element 1, 2, and all element of this is also element of A. So this is a subset of this. I am not mentioning with any name, but this is subset of this. So such kind of all the subset you find, like I start subsets. 1. Does 1 is subset? Yes, because it is 1 and it is 1 also. So all the elements of this set is also element of A, so that it is subset. Now 2. Does this subset? Yes, because all element of this set is also subset of this. Don't afraid that I am not mentioning with any name. This is subset, yes. This is subset. And any more? 3 is subset. 3 is subset, yes. 1, 2 is subset, yes. 2, 3 is subset, yes. 1, 3 is subset, yes. 1, 2, 3 is also subset, because I told that every set is subset of itself, meaning 1, 2, 3. All 3 elements are lying in that. So it is also subset. And one major thing which you cannot see, which is actually phi. Phi is a null set containing no element. So I would say that, does it here? You will say yes, because it is no element, can be placed anywhere. So this is last sentence, very confusion sentence, but still it is a true that as 1 is appearing here, 2 is appearing here, this is nothing, so nothing here. You can say that the phi is always a subset of any set. Phi is always, as itself 1, 2, 3, itself whole set 1, 2, 3 was a subset of 1, 2, 3 set. Similarly, phi is subset of any set. Keep in mind that phi is a subset of all the sets, any set. So these are now 8 subsets of 1, 2, 3. Look at A is equal to 1, 2, 3. We have got 8 subsets. Okay, I put one more example to you. Suppose A equal to A and E. Find all the subsets. Look at what subsets will be. First is A, comma, E, then AE both, and lastly, it's a famous phi. How many? 4. How many? 4. Meaning, look at, I have a formula to you. This is 3 element. So we got a 8 subset. We have a 2 element. We got a 4 subset. So if, look at properly, if A has n elements, so number of subsets of A will be 2 to the power n. This is very important formula, guys, and nothing hard word. A has n element. Look at, A has 3 element. So how many sets here? How many sets? If A has 3 elements, look at, if A has 3 elements, how many subsets? The number of subsets will be, formula, 2 to the power n, n meaning 3. 2 to the power 3 is equal to 8. 8 subsets. Second question. A has how many element? 2. Number of subsets are 4. Okay. And A has 2 elements. So number of subsets will be 2 to the power 2. Look at the 2 to the power n. N meaning number of elements in set A. That much will get a number of subsets. Meaning answer is 4. So this kind of a objective question may come that A might have given with some elements, and you would be asked that how many subsets there are. You just have to use a formula 2 to the power n, put n equal to number of elements and get your answer. So this is the concept of subset. So further I will tell you the properties of subsets tomorrow. This is good enough. Just try to understand about and do example number 9, 10 and 11 by yourself. Thank you.